Hello everyone, my name is Mafla and I'm a PhD student at Autonomous University of Barcelona. I am going to present our work called Is an Image Worth 5 Sentences? A new look into semantics for image text matching. So, as we know, we focus on cross-modal retrieval between images and captions. In the figure, we can see that given a query, both methods are equally good according to the standard recall. However, if we consider the semantic relevance of the retrieved samples, model B is clearly better. Therefore, recall metric has some limitations. First, the recall is binary, it labels a retrieved sample as relevant or irrelevant, and second, it does not consider the degree of semantic relevance of retrieved items. In this work, we identify the shortcomings of commonly used recall at K metric in the image text matching task. We define a new metric, namely Normalized Cumulative Semantic Score, NCS, that evaluates the degree of semantically retrieved samples of a model. At training, we propose a novel semantic adaptive margin, SAM, incorporated into a triplet loss that defines similarity among samples without human annotation, and by incorporating SAM into training, yields state-of-the-art in different ITM models. Our proposed metric basically is the ratio of the retrieved samples of a model divided by the sorted maximum semantic score of all samples in the dataset at a cutoff point k. In the figure, the NCS score at 5 is shown. To obtain the degree of similarity, a comparison is obtained between the query and the 5 captions that describe the image. We rely on automatic image captioning metrics such as CIDR and SPICE. For instance, we can observe that even recall is 0 in CVSE, the real performance is not. CVSE plus SAM shows an even higher degree of semantics among non-GT relevant samples. We also show that by employing the NCS score, a higher correlation with human judgments is achieved. In order to do so, we employ the crisscross dataset on MSCOCO as the ground truth. We also noted that our metrics showed that the gap between state-of-the-art models in non-GT items seemed to disappear. So the conclusions are that the real generalization capability of current ITM models is somewhat limited. The gap among non-GT samples of current image text matching models is way smaller than considering only GT samples. In the figure, we can see the comparison of a fixed margin loss function on the left and our adaptive margin right. We consider an image anchor I, their positive sentences according to the ground truth, C1, C2, C3, and 4 other sentences, C hat, that are negative according to the ground truth but have some degree of semantic similarity with I. In our method, we dynamically adapt the margin of each possible triplet to the value given by a similarity function that measures the semantic similarity of positive and negative items. These ones are CIDR and SPICE. In a reduced data scenario, we propose an analysis that uses 10 and 25% of the Flickr30K dataset and 3 and 5% of the MSCOCO dataset. We use these percentages to have comparable training data sizes. We can observe that by employing the semantic adaptive margin, the models converge faster and require less data to achieve a better performance. It outperforms the current state of the art by a factor of 2 to 10 times depending on the scenario and the model. On the standard image text matching task, we can observe that by plugging the proposed SAM, a boost in recall is achieved. Secondly, both metrics have a degree of correlation. However, a boost in recall does not necessarily translate in an increase of NCS. However, the retrieved samples are higher in semantics. The qualitative results show the performance of the original CVSE with and without SAM. Retrieved captions contain a higher degree of semantic relevance. We can see this effect even improved in Flickr due to the higher fine-grained interactions between images and captions. In text-to-image retrieval, we can see the same effect. By plugging our SAM, more semantically relevant samples are retrieved. Additionally, the proposed metric depicts the semantic relevance of non-GT retrieved samples, which is far from a simple 0 given by the standard recall. We can see some samples and improved semantics as well. And to conclude, we showcase the shortcomings of the uses of the recall at K metric. We rely on image captioning metrics such as CIDR and SPICE, and we propose a new metric, Normalized Cumulative Semantic NCS score, that measures the relevance of non-GT annotated retrieved items. We introduce the SAM to dynamically learn a margin among triplets, and a very important boost in low data scenarios as well as a faster convergence is achieved. Code is available. Thank you.